Hello students, I Swati here again with a new video of chapter 1 number system. In the previous video we have studied about number system, decimal number system, binary number system, and we also have studied about conversion from decimal to binary and binary to decimal. So today we will start from octal number system. As I told you before, we have four types of number systems: binary number system, decimal number system, octal number system, and hexadecimal number system. So today we will start from octal number system. The octal number system consists of 8 digits from 0 to 7 with the base 8. The concept of octal number system came from the Native Americans, as they used to count numbers by using the space between their fingers rather than using their fingers. Now, the procedure of octal to decimal conversion is similar as we have done binary to decimal conversion. So just see how can we convert octal number into decimal number. So same method we have to apply. We have to start multiplying the digits of the number from the right hand side with increasing power of 8 starting from 0, and finally calculating the sum of all the products. Just we will understand this with an example. So we have octal number 422 with the base 8. Now we have to convert it into decimal. So we will start from the rightmost digit, that is 2. So firstly we will multiply 2 with 8 raised to the power 0. Then we have to pick 2 multiply by 8 raised to the power 1, and then we will have to pick 4 multiply by 8 raised to the power 2. So we can see that the power of 8 is in a increasing way. Now we will have to calculate this, and then we will see the result 274. Thus 422 base 8 octal number is converted into 274 base 10 decimal number. So this is the way to convert octal number into decimal number. So next we will understand about hexadecimal number system. This number system consists of 16 digits, numbers 0 to 9, and the letters A to F, where A to F represent decimal numbers from 10 to 15. That means A is equivalent to 10, B is equivalent to 11, C refers to 12, D refers to 13, E refers to 14, and F refers to 15. The base of this number system is 16. This number system is also known as hex. Now, conversion of hexadecimal into decimal number system. For this, we have to follow the same method that we have followed before while we were converting binary to decimal and octal to decimal. So same method we have to use here. So this we will understand with an example. Here we have number 5F2. On the place of F, we will use 15 because the value of F is 15, as I told you before. So now for converting this into decimal, we have to start from the rightmost digit, that is 2. And we have 16 base here, so we will use 16. So 2 multiplied by 16 raised to the power 0, 15 multiplied by 16 raised to the power 1, and 5 multiplied by 16 raised to the power 2. Now we have to solve this, and then we will see the result 1522. Thus 5F2 with the base 16 hexadecimal number converted into 1522 base 10 decimal number. So this is the way to convert hexadecimal number into decimal number. Okay, now these were the types of number systems. So now we will understand about computer arithmetic. As a computer understands only the binary code, so the data entered into the computer by the user is converted into binary code for processing. This processing may involve various kinds of arithmetic operations such as addition, subtraction, multiplication, division, etc. on the binary numbers. So we will see how can we perform these calculations, these processing on the binary numbers. So we will start from binary addition. The technique used to add binary numbers inside the computer is very easy and simple. This is performed in the same way as we perform addition with decimal numbers. We have some rules whenever we are adding binary numbers. So this is a table. By this table we will understand the rules to add two binary digits. So first, if you have 0 plus 0, then the answer will be 0. If you have 0 plus 1, the answer will be 1. If you have 1 plus 0, the answer will be 1. And if you are going to add 1 plus 1, so the answer will be 1, 0. But if you have another numbers to add, then you have to use 0 as a result and 1 as a carry. That we will do in decimal numbers as well. So I want to share a thing. While adding 1 plus 1, the output will be 1, 0, where 0 is written under the same column and carry over 1 is shifted to the next place, as it happens in the decimal numbers addition. Now we will understand this with an example. We have to compute 10002 plus 1111. We have to add these numbers, these binary numbers. So for that, we are placing the numbers 1000 1111 and the output is 101111. So as I told you, with the help of table, 0 plus 1 equals to 1, then again 0 plus 1 equals to 1, then again 0 plus 1 equals to 1, and when we are adding 1 plus 1 equals to 1, 0. If we have some another number here, so the 0 will be here and the 1 will be go to the carryover. So this is the way to perform addition, binary addition. Now we will understand how can we subtract binary numbers. So there is a table. There are the rules that we have to understand. So whenever we are going to subtract 0 from 0, the result will be 0. When we are going to subtract 0 from 1, the result will be 1. When we are going to subtract 1 from 1, the result will be 0. And when we are going to subtract 1 from 0, so the result will be 1. When we are going to subtract 1 from 0, we have to borrow. So whenever we are going to borrow some number, so we have to subtract like this, 1 0 minus 1, so the result will be 1. Now we will understand this with an example. We have to compute 1111 base 2 minus 1010 base 2. So we have to manage them like 1111, then 1010, and the output will be 0101. As I told you, when we are going to subtract 0 from 1, the result will be 1. When we are going to subtract 1 from 1, the result will be 0. 0 from 1, the result will be 1, and 1 from 1, the result will be 0. This is the simple subtraction that we have performed right now. Now we will understand how to borrow numbers within another example. So now we are going to subtract 11 base 2 with the number 1100 base 2. So for that we have to arrange the numbers like this. Okay, so now if you want to subtract 1 from 0, we have to take borrow the number from the next number. Next number we have 0, so we cannot borrow from 0, so we have to borrow from 1. So if we are borrowing the number from 1, the number will be 1 0. So as we know, 1 plus 1 makes 1 0. So we have two ones here. So 1 1 we are taking from here. Now this will be 1 0 minus 1 and the result will be 1. Here the balance will be 1. So 1 minus 1 is equals to 0. Here the balance is 0. So 0 minus 0 is equals to 0, and here 1 minus 0 is equals to 1. So this is the way to subtract the numbers by borrowing the numbers from another number. Now we will understand the multiplication. How we can multiply binary numbers. For multiplying the binary numbers, we have some rules. So whenever we are going to multiply 0 with 0, the answer will be 0. 0 with 1, the answer will be 0. 1 multiplying by 0, the answer will be 0. And 1 multiplied by 1, the answer will be 1. So these are the rules for performing multiplication, and that we will understand with an example. So here we are going to multiply 10 base 2 with the number 110 base 2. For that we have to arrange the numbers like this, and now we are going to perform multiplication. So from here I'll pick 0 and multiplying with these three numbers. So 0 multiplied by 0 is 0, 0 multiplied by 1 is 0, 0 multiplied by 1 is 0. Now I'm picking 1 and multiplying with these three numbers. So 1 multiplied by 0 is 0, 1 multiplied by 1 is 1, and 1 multiplied by 1 is 1. Now for getting the result, we have to add these numbers as we have done before the binary addition, same as we have to do here. So here we have the result 0, 0 plus 0 is 0, 0 plus 1 is 1, and 1. So the result is 1100. So this is the way to multiply binary numbers. Now we will learn how to divide binary numbers. So the method to perform division of two binary numbers is same as that of decimal numbers. So we will understand this with an example. So here we are going to divide 1010 with the number 11. So we have to arrange the numbers like this, 1010 and 11 here. Here 11 is the divisor. This 11 is the quotient. This is the dividend, and this is the remainder. So how we have performed this, just see. So here 10 is less than 11, so we will use these three digits 101. So we have put 11 here. Now we have to subtract 11 from 101. So here 1 minus 1 is 0, and 0 minus 1, for that we have to borrow a number. So we are borrowing 1 from here. So 10 minus 1 is 1. Now again 10 is less than from 11. So we are picking this 0 here. So here the number is 100. Now we are putting 11 here again, and now we are going to subtract again. So if we are going to subtract 1 from 0, again we have to borrow the number. We can't borrow from 0, so we are borrowing from 1. So here the number will be 10, and as we know 1 plus 1 makes 10. So here we have two ones, so we are borrowing the number from here. Now here we have 10. 10 minus 1 is 1. Here 1 will be left, so 1 minus 1 will be 0, and here the 0 will be balanced, so here the 0. So this is the answer, this is the remainder, and this is the way how we can perform binary division. That's all with the chapter. Just watch both the videos carefully, try to understand the conversion, try to do the processing, try to do the addition, subtraction, multiplication and division of the binary numbers. If there is any problem, I'm available anytime. You can ask me. Thank you.